Dr. G. Prakash.
Good evening, ma'am.
Yeah, hello, how are you?
Yeah, I am fine.
I could see both the session chairs are present there, and the keynote speaker, Dr. Amanda Muller, is also there with us. And a few participants have already joined, and people are coming in. So let us start the session. We have with us our two session chairs. We have Dr. Asha Subramanian with us. She is founder and CEO of Semantic Web India, Bangalore, India. And we have with us Dr. G. Prakash from Amrita Vish Vidyapeetham, Bangalore again. So welcome to the session chairs, and over to you to take over the session, please.
Sure. Dr. Prakash, did you want me to introduce Dr. Amanda, or would you like to go ahead?
I will just, yeah, whether I'm audible?
Yeah.
Yes, you're audible.
Yes, fine. I saw the authors for.
We can't hear you well. I'm not sure whether I'm the only one here who's unable to hear you.
Yeah, Dr. Asha, you please kindly introduce the keynote speaker,
Sure.
and then we go ahead with her talk.
Yeah, yeah.
Thank you.
Sure, sure. A warm welcome, everyone, to the second half of today's ISIC conference. And a warm welcome to you, Dr. Amanda. We really look forward to your keynote talk. Just a few words to introduce you. Dr. Amanda Muller is the responsible AI lead for Northrop Grumman Mission Systems. She is responsible for coordinating the strategy, policy, and governance efforts related to artificial intelligence across the Northrop Grumman enterprise. She's also the Mission Systems Technical Fellow Emeritus, specializing in user experience and human systems integration. She is also the subject matter expert on proposals, program reviews, and research efforts. Dr. Muller holds a PhD in engineering from the Wright State University in Dayton, Ohio, and BS and MS degrees in biomedical engineering from the Worcester Polytechnic Institute in Worcester, Massachusetts. She also holds a graduate certificate in design thinking for strategic innovation from Stanford University. Dr. Muller is a certified systems engineering professional, a professional Scrum Master, and is also certified in professional Scrum with user experience. I extend a warm welcome to Dr. Amanda, and we look forward to your keynote speech today. Thank you.
Thank you very much. And can everyone see me, hear me, see my slides?
Yes, you are quite audible, and your screen and your presentation is also visible.
Excellent. Thank you so much. And thank you for having me at this conference. I was asleep during your first session today, so I apologize I didn't get to hear the talks. It's still early in the morning here in Washington, D.C. But I did get to attend some of the talks yesterday. So I'm going to give a little bit of a different focus here today. And the focus is going to be specifically on human-machine teaming and how we can enable our AI systems to interoperate with our human teammates. And AI ethics can be an enabler for that. So my primary thesis and what I would like you to keep in mind as I present here today is that AI ethical frameworks can be used as a guide for how we create high-performing human AI teams. Now, I'll spend a little bit talking about why this is important. To me, as someone who works for a defense contractor, Northrop Grumman is primarily working with the US government. We are a global company. We work with governments around the world. But myself here in Washington, D.C., I'm primarily working with the US government and with our allies to create things that work for our military. And when we're working in a military context, things are very challenging. I mean, AI is hard no matter where you do it. But when we are talking about operating in an environment where we are constantly subject to attack, things get even harder. So every surface of our AI systems is subject to adversarial attack. The software, the hardware, even the trust that our operators have in our AI systems can potentially be attacked. So if an adversary can erode that trust that the operators have, then our AI systems no longer become effective because the operators simply won't use them. And that's in addition to cyber attacks, to the potential, oops, I don't know why my slides are automatically advancing, for the potential for our training data or our testing data to become biased. All of these are challenges that we need to face when we're developing AI systems that are going to be operated in contested environments. Now, our National Academies for Sciences, Engineering, and Medicine earlier this year released a report that discussed human-machine teaming in AI and just how important that is in order to make sure that our AI systems are effective. And this is regardless of the domain in which we're operating. So I'm going to very quickly talk about this chart right here, but I'm going to dive deeper into it in a couple of slides. This outlines all of the areas that we need to focus on and research in order to make sure that our AI systems are effective. So it's not enough to just build the algorithms and to test the algorithms. We have to do that in the context of our human teammates. So we need to measure the performance of our human AI teams, not just the algorithms themselves. We need to look at team biases. So not just the algorithmic biases, but also the biases that the human beings bring to that system. We need to look at trust, situation awareness, the explainability and the transparency of our interfaces so that our human teammates can understand what the AI system is doing. We need to model the interaction between the humans and the AI, and then we need to train everybody. We train teams all the time. If we have a team of soldiers that is working together, we put them together and we do training together. It's the same with a team that involves an artificial intelligence algorithm. We need to train that team together. And throughout all of this, we need to have the processes in place to do this development. We need to be able to measure how well we do it, and then we need to test. So I'm going to talk about each one of these in a little bit more detail. But first, I want to give just one more piece of evidence for why this is important. Early last year, in 2021, the National Security Commission on AI finished its work and put out a final report. And this final report's available out there on the internet. If you would like to take a look at it, it's very comprehensive. It's about 750 pages, but they have a really great website that lays out all of the main points of this report. But the one I want to highlight here is, I'm going to read the first sentence and then paraphrase it. If AI systems routinely do not work as designed or are unpredictable in ways that can have significant negative consequences, then leaders will not adopt them, operators will not use them, Congress will not fund them, and the American people will not support them. So this report is saying we can create the greatest algorithms in the world, but if we put them into the field and they don't work in the way that we expect them to, then we've essentially wasted our time because they're simply not going to be used. So we need to establish justified confidence in our systems. And the report was saying that our government, the US government, needs to focus on ensuring that our systems are robust and reliable, including through research and development in AI security and in advancing human AI teaming. So this is what we need to do to make sure that our systems are fully effective, that they will be used. We need to work on our human AI teaming. Now, how do we do that? We have all those research areas, but the main thesis, remember, that I have here is that we can use ethical frameworks as a way to enable that human AI teaming. And there are so many ethical frameworks out there for artificial intelligence. The United States intelligence community has its own ethical framework. And the main points of that are on the left-hand side of the slide. So if I'm developing something that works with and for the United States intelligence community, this is a framework that I may look at. And you can see some words here that continue to come up through a lot of different ethical frameworks: accountability, bias, explainability. These are all things that we need to pay attention to in order to make sure that our AI systems are going to function appropriately with our human teammates. If we want to move outside of the government, the Business Roundtable recently put out a roadmap for responsible AI. And the Business Roundtable is a group of about 200 CEOs of large companies. My company is a member of the Business Roundtable. And of course, our CEOs are very busy, so they delegate this down. So I was a member of the group, even though I'm not anywhere close to a CEO of this, the team that put together this roadmap. And one of the things that we recognized as we were developing this is that there is no one-size-fits-all ethical framework that's going to work for all 200 companies that are members of the Business Roundtable. You've got companies like mine, which are defense contractors. You have commercial companies that are developing technology like self-driving cars. You have companies like Google and Amazon that have very, very different applications of artificial intelligence than we have within the defense industry. So the use case very much matters. What we're trying to do with the AI matters when we're talking about what does it mean to be ethical? What does it mean to be explainable? So this framework that we built with the Business Roundtable had to be very high level and very generalizable so that then we could drill down and make sure that we were doing the right thing within the use case in which we're operating. And then any company will probably also have a set of ethical principles, maybe specific to AI. My lawyers wouldn't let me put any specific examples on here, so I kind of brought a couple together. Many of them are similar. They talk about the purpose of artificial intelligence for their company. Many of them talk about creating AI for the benefit of people, which is a very noble goal. But then you also see these same words coming up: bias, accountability, transparency, that you see in many of the ethical frameworks. So a lot of overlap, but also some specificity depending on where the framework is applicable. So we need to select the right ethical framework for the use case in which we're operating, and then we need to drill down within that ethical framework to make sure that we're developing it in a way that aligns with our use case. So how do we select the right ethical framework? Number one, we need to look at the domain. So as I said, many of these principles overlap, but if I'm operating in the defense domain, my ethical considerations are going to be very different from those for a commercial company. So if I were working for Apple instead of Northrop Grumman and I was developing the facial recognition algorithm that opens up my iPhone, then I have to be very concerned about racial bias and gender bias and making sure that my facial recognition algorithm works for all different types of people. So I'm going to be very focused on those types of ethical considerations. If I'm developing instead for my current company, Northrop Grumman, a target recognition algorithm that's looking for tanks that may be a threat to my troops, I'm not going to be so much worried about racial bias or gender bias. That doesn't factor into the equation, but I need to very much focus on other types of bias that may exist within my data sets. So the application domain matters when we're thinking about what ethical framework applies. The second thing to consider is who is the affected population. So who are going to be the users of your AI systems and whose data are you using? So there may be laws that apply. The European Union and Great Britain have very comprehensive and very specific laws about how individuals' data can be used. So if we are developing anything that collects data from UK citizens or that will operate in the UK, we have to look at their ethical guidelines to make sure that we follow those. But if we're working within the United States, then we may have to look at state guidelines and who the users are that are being affected. And are they a vulnerable population? This is also something that's incredibly important to make sure that we take into account the harm that could be caused to the user's data that we are potentially using and what ethical guidelines we should be following in order to make sure that we reduce or minimize the risk of harm. So all of these things are factors to consider in selecting an ethical framework. I'll leave you to think about those and look for ethical frameworks that apply to your specific area. But for me, for the most part, it's going to be the US Department of Defense, their vision of AI ethics that's going to guide the work that I'm doing. So I'm going to give some examples and do that deep dive related to the US Department of Defense's vision of AI ethics. The DoD has 5 principles for responsible AI: responsible, equitable, traceable, reliable, and governable. Now, this is a very high-level framework. They just provide a few sentences on each, and then it's up to us to say, what does that mean for the use cases that we're developing? So I'm going to drill those down related to building that human-centered AI foundation, making sure that we can build effective human AI teams using this ethical framework as a guideline. So that first principle is responsible. That means human beings must maintain personal judgment in the development and use of AI. So for me, as someone who's designing AI systems, That means that I need to make sure that the human beings who are working with that system are always fully able to maintain that level of responsibility. So I need to make sure that they are given tasks within the human AI system, that the functions that I give to the human and the functions that I give to the AI are things that are appropriate for each of them, that they can execute well, and that the human beings always have control over the AI system. The second principle is equitable. And this is where the bias comes in. We need to make sure that we understand our sources of bias and that we can effectively mitigate those sources of bias or mitigate the risk associated with them. We will never get rid of bias completely. There will always be bias in our AI systems. There will always be bias in human beings. So we need to make sure that we understand what the sources of bias are and that we understand what the risk is and that we can mitigate that risk appropriately. The third principle is traceable. So this means that the system itself needs to be auditable. We need to know where our data is coming from, that the sources of that data are trustworthy, and we need to provide insight into every step of the way, the provenance of that data. And this goes not only when we're in system development, but also when we're in operations. We put our AI systems out there into the world, they're collecting new data, they're changing, they're getting new information. We still need to have that data provenance every step of the way, and we need to log how this progresses, what information we're getting and how we're using it. And the fourth principle is reliable. This means that the system does what we say it's going to do and that we can trust the results of it. So we need to understand our use cases. We need to understand where our systems work and where they don't work. So we need to test. And that, again, does not end when we deploy. It continues throughout the operation of the system. And then we have to communicate those limitations to our human teammates. So if, going back to my target recognition algorithm example, if I've created an AI algorithm that can look for tanks in the desert and decide if they're a threat to my troops, but now then we've moved into a forest environment. Is the system still reliable in that environment? If it's only been trained on tanks in the desert, can it recognize tanks in a forest? I need to be able to communicate that level of reliability to the warfighters who are relying on this system so that they know whether they can trust the data and whether it's reliable. All right, the fifth principle is governable. This means that the system operates as intended, but if it doesn't, if now we're starting to move outside of our intended use cases, if things aren't as reliable as we want them to be, we're able to take it offline and have a human take over, or have a deterministic system take over, or switch to another algorithm that's going to be more reliable. We need to have that governability built in. Important to be able to do this when we're working with human beings is that the system needs to be explainable or interpretable. I like the word interpretable rather than explainable, because explainability, you can explain something and not have it be understood by the recipient. So we need to make sure that it's understood. We need to make sure that our human operators are able to interpret the results of the AI system. And that's how we're going to allow it to be governable. All right, so now let's bring this back to that human machine teaming graphic. Each one of these ethical principles aligns with one or more of these human AI teaming elements. So if we can use these ethical principles as a guideline, and we can execute the type of processes, measures, and testing that we need in order to enable human AI team performance, now we're in business. Now we know we can create systems that are going to work with our human operators. So let's dive into each one of these individually and talk about what those processes, measures, and testing are. We need to enable each one of these ethical principles. So starting with responsible, making sure that human beings maintain responsibility. What processes do we need in place in order to do this? First, we need a robust human systems integration program. So we need human factors engineers, user experience researchers, human factors psychologists to be part of the development team. We can't send our algorithm developers off into a small room, shut the door, and throw pizza under it every once in a while to keep them going. We need people who are experts in understanding how technology works with human beings to be part of that development process. That's what's going to allow us to design features of that system that will enable human beings to be responsible. We also need our development and operations teams to be trained in AI literacy. So, for the most part, our developers who are developing AI understand AI. But in many cases, especially in areas where I work, we may have people who are operating the AI systems. These could be 18-year-old soldiers who have no experience in artificial intelligence. So we need to train them. They don't need to be experts in coding. They don't need to develop algorithms themselves, but they need to be able to understand what AI does and what it's telling us so that they can maintain that level of responsibility. So how do we know we did this well? We need to test. We need to test the performance of the human AI team. And I know as developers, a lot of times, we want to test the accuracy of the algorithm. We want to, get our confusion matrix. And if we do that, everything's grand. But we need to factor the human in here as well. So our testing is not really done unless we've tested the overall system with the human included. And we also need to test their usability. So a human is not going to be able to operate an AI system to be responsible for the AI system if they can't use it or if it's clunky. So we need to make usability a part of our testing protocol as well. And then situational awareness also needs to be part of that testing. So, this goes into the human team performance, but understanding if the human is situationally aware of everything that's going on is what's going to allow them to be responsible for the AI system. All right, so that's our responsible. Now let's look at equitable. And remember, this goes to understanding and mitigating biases, not just within our data and our algorithms, but the overall human AI team. So the number one process we need in place to make this happen is a data governance structure. We need that structure in place to know where our data is coming from, if we can trust it, if the data is biased. We have to have that governance in place. We need a robust risk management process. Remember, we'll never get rid of all of our biases. So it comes down to what's the risk associated with those biases, and we need to track that risk. On the programs that I've worked on, we always have a risk management framework. We have a risk register, we have a risk board that meets once a week or every other week, where we look at what our risks are. So these bias risks, these equitability risks need to be part of that risk management structure. And then we have to monitor continuously during development, during deployment, during operations. So we need to know if our risk is increasing, if we're mitigating it, what are the biases in our data that we have during training and during deployment. And one of the best ways to identify potential sources of bias is through employing diverse engineering teams. So we need to have the right skills on the team, including that human factor psychology, so that they can understand the potential human biases. But also, one of the best ways to increase innovation, to make sure that you're thinking in different ways, that you're identifying sources of bias that maybe aren't completely obvious, is to have people on that team who don't look like you. So gender diversity, racial diversity, those are all ways that we can enable our teams to better recognize sources of bias. So how do we measure this? How do we test it? We need to actively work to identify sources of bias. This needs to be part of the way that we develop and operate. Counterfactuals are a great tool to be able to do that. Try to break your AI algorithm, see where it fails, and that can help us to identify where our biases might be, and then making this part of our risk assessment. And we are working with a third-party company out of Silicon Valley called Equitable AI. And they are helping us do bias testing. So, we're bringing in somebody completely from outside our company so that they can look at things with fresh eyes. And they have algorithms that can help us test for bias, and then do assessments of our tools. And then we also need to monitor for downstream effects. So I know I've said this probably 50 times already, but our job isn't done once we deploy our algorithms. We have to continuously monitor. We have to see what the outcomes are, and if they're different from what we had planned, that's also going to help us to identify what the biases might be in our system or in our data sets so that we can work to mitigate those. All right, our next principle is traceable. This is how we build trust. We show the provenance of our data. We show the provenance of our algorithms in a way that the human operators can understand. This doesn't mean just handing over our code, especially if we have operators and human teammates who are not AI developers. That's that 18-year-old soldier who doesn't know anything about artificial intelligence except for what it is and what it can do. We need to present the information about data and algorithm provenance to them in a way that they can understand. Provide that model transparency. So again, we need the right people on the team. We need to have that user research, the UX design, the human factor psychology who can design that information flow in a way that's going to make sense to the operator. And we need to train them. So we can't expect AI to be intuitive. And that breaks my heart to say, as somebody who's worked in user experience for much of my career, that we work very hard to make software so intuitive that you don't need a user manual. That's just not realistic for artificial intelligence systems. So we need to develop that training in a way that's meaningful to the operators. And here's also where we need to allocate functions appropriately to our human teammates and our AI teammates. So when we're building an AI-enabled system, we need to give our human operators the responsibility for things that AI is not good at. And that includes things like understanding the context in which the system operates, the socio-political context, the potential ramifications of decisions. AI doesn't know that. Human beings know that. And human beings are also the ones that are responsible for making the decisions of whether something fits within the ethical framework or not. So we build trust in our human AI systems. We build that traceability by making sure that we have done this appropriately. So how do we measure this? We do that risk assessment, we measure the overall performance, and we measure the usability. And now you're going to start to see many of these repeating because most of the measures are very similar. We need to make sure that our human AI team is performing appropriately. And if we've done that, then we know that we've built these systems correctly. Key, though, is designing that assessment in a way that measures these specific principles. Let's go to reliability. So again, this is making sure that the system operates as we say it was going to operate. So we need to measure that, and then we need to work to improve the reliability over time. Transparency is key here, the right people on the team, the training for the operators, the right function allocation. But here where we also need to introduce model drift adjudication. So as we put our AI systems into operations, and as they bring in new data and they take in new information, things are going to start to drift from the originally designed purpose. Sometimes that's a good thing. If we're operating in a new environment that we haven't seen before, then it's good that it's taking in new information about that environment. But sometimes other things may creep in. Some of those biases in our data may creep in, and we need to actively measure that and see if it's a good thing or a bad thing, and if we need to adjudicate it. And that comes back down to the well-defined use cases. I don't know, it was very popular in the United States. I don't know if this reached around the world, but there's a game show called Jeopardy. It's been around since I was a kid, decades. And IBM, the company IBM, developed an AI tool called Watson that they made play Jeopardy, and it beat the human champion who had won more games than anyone else in the history of the show. So everybody was really excited about it, that an AI could beat this incredibly intelligent human at this game show. And everybody said, oh, IBM's Watson is going to take over the world. Well, they started applying Watson to other use cases, specifically healthcare. And just earlier this year, they finally pulled the plug on their healthcare system. Watson was very, very good at playing Jeopardy. Watson was not very good at answering questions or doing analysis within the healthcare domain. The use case really mattered. So they did their best, but it just didn't work within that other use case. So we need to test. We need to test the performance based on the use case and be very careful about communicating the reliability within the use case. Watson was 100% reliable at playing Jeopardy. It was like 5%. I'm making this up. Don't quote me on it. 5% reliable in the healthcare domain. And finally, governable. So this is our final principle. Governable is about providing for human AI interaction, transparency, and explainability. So making sure that human being can maintain the governance of the AI system. So same processes of model transparency, the right people on the team, the training for the operators, the function allocation. The new thing here is the explainability and the interpretability. So this has to be a requirement of any system, any AI system that's going to operate with a human being. We have to make sure human beings can interpret it. We have to make sure that our AI systems are not a black box if they're going to interact with a human in any meaningful way. Because the human's not going to be able to govern that system if they can't understand it. They also won't be able to trust that system. So we make sure we do this through the same measures, just with a different focus, through measuring the performance, measuring the usability. All right, now all of this is easy to say. It's a lot harder to do. But it's going to require, not just technologists, but it's also going to require the appropriate stakeholders on the ethical side of things. So again, I primarily work with the US government. So they're going to be the policy developers that we look to develop these policies, develop our requirements. And then we, as technologists, as people who develop software, are developing the best practices. And bringing it all together is governance. So we need to make sure that we are doing the things that we say we're going to do. Don't just take our word for it, but we need evidence for that. And then all of this circles back together. So in order to make sure that we're compliant with our requirements, we collect evidence, we put that information into the dashboard. My slides have a mind of their own. But then it requires both us on the vendor side and the non-technical stakeholders on the policy side to come together and agree that we've met the purpose of these requirements. So this is an all hands on deck type of situation. We really need to work together to make sure that we're developing AI systems that work for our human beings. But if we have the right ethical frameworks, if we have the policies in place, and then we have the technologists and the user experience professionals and the human factor psychologists working together, implementing these processes and these measurements, then we have a really good chance of building AI systems that will work for humans. So to sum up, hopefully I've made the case that ethical frameworks can be used as a guide for creating high-performing human AI teams, and I will open up the floor to any questions. I see we have some questions in the chat from Dr. Bhargava, of course. So specific problems we can help to work to help at Northrop Grumman. And you have your hand raised too. Do you want to say anything?
No, I was very happy to, very delighted to see you and listen to your presentation. But many of these small things that you mentioned, they're big things for us, like responsible, equitable, traceable, reliable, governable. So when we want to do a PhD thesis, we can pick up one of these topics and then go deep into the things that we can develop that could educate people at Northrop Grumman, as well as give them some way of thinking or developing new ideas. So I was just wondering, this looks like a very very big project that only Northrop Grumman can form a team. But I was just looking at, from the academic point of view, any suggestions that you might have.
Yeah, thank you for the question. And this is a big problem for us too. And I don't want to give the impression that we have solved it. These are our recommendations for how we might look at the problem of human AI teaming. And for a PhD student to tackle one of these areas, on a specific use case even, I think would be incredibly beneficial. So if we wanted to look at, what information does an 18-year-old soldier need from imagery that was collected and processed by an AI system in order to trust it? I don't have the right answer to that question, because I think it very much depends on a number of factors that we haven't studied yet. So if we could, just take pieces of this, what information is needed? How do we make that particular type of algorithm explainable to a human being? A lot of this hasn't been done. A lot of this research hasn't been done. And if I go back to, sorry, I don't want to make anybody dizzy. Here we go. To this slide, and the link is down here at the bottom of the screen, or you can just Google the title, the Human AI Teaming State of the Art and Research Needs. This was a very comprehensive study that was done by the national academies, by experts in human machine teaming. And it is full of potential research topics in this area, the things that we need to do to study in order to say, do we have effective human AI team performance in a particular area? How do we build trust? There is no shortage of things that could be researched and explored.
Yeah, I fully agree with you. All these operating systems, database systems, network monitoring, this requires a lot of expertise. Is the same thing for the AI system. So one of our very famous professor from Berkeley, he used to tell me that you got to build systems that are as easy to use as driving a car. So as you said, 18-year-old should be able to handle it. What he was heading towards is 18-year-old should be able to handle a very complicated machinery of a car. So I agree with you that we need to build systems that are very usable. And and one other question I had was, you said that the AI system is not good at looking at the political context. Can that be entered? For example, in the AI system, you could say if the information is coming from an adversary, we can give it a lower priority than if it's coming from a friendly country. So for example, if the information is coming from Russia in Ukraine, they will depend on it less than if it was coming from US. Can you build that
Sure.
into the AI?
Yeah. And I think that's a little bit different from what I meant by political context. So, I'm thinking more the decisions that are made. So if, for example, I've got my target recognition algorithm that's looking for tanks in the desert, and my AI gives me a 95% chance that this is a tank that's coming after my troops and I should blow it up. But it's on the border between Russia and Ukraine. Is 95% good enough right now, given the current situation, for me to be able to trust that? I think we need a human being to make that determination. The AI doesn't have a good understanding of the context of the war in the Ukraine currently. So that's just maybe not the best example, but an example of humans have access to different types of information than maybe were conceived of when the AI was created. So
Yeah,
we need to allow them to take that information into account.
Yeah, I agree with you. This will cut down the friendly fire, number one. And number two, for example, if you are in a different country like Afghanistan, you have to know the culture of that country and how schools are built right next to the, bad people, Taliban. So you have to know all that, and AI system cannot be fed all that information. So I agree with you.
Yeah.
Thank you.
Yes, you're welcome. Thank you for the questions. Dr. Prakash, I see you have your hand raised as well.
Dr. Amanda?
Yes.
Yeah, fine. So it was a nice talk. So I'm having a question. The attacks.
Sorry, I'm only catching like every other syllable. I think it's a little better if you hold your microphone to your mouth.
Oh, yeah. So you spoke about various cyber attacks related to the AI. So the question here is, today we are having various cyber law that has been promoted by the countries, and also still these particular cyber laws are not coping up with the present attacks. So if we are talking about this particular ethical framework and the ethics, what we are following with respect to AI, So how this can be transformed into the cyber laws that can be refined in the present scenario? Is there any procedure to follow that? That's my question.
Yeah, that's a really great question, and I don't have a great answer for you because it's hard. It's really complicated, and we have, every time we come up with a law or a framework to prevent cyber attacks, and cyber attackers, figure out some other way to get in. So I think for me, and this is probably my own bias as a systems engineer coming in, but the most important thing is to have the process in place to make sure that we can continue to adapt to the changing situations in the cyber counter cyber community, and continue to look at the new ways that our systems could potentially be attacked. I don't think there's a neat, tidy answer of if we do this, then we'll be good for all time. We need to make sure that we have the processes in place that we continue to look at what are the ways that our AI systems are vulnerable and how can we counter those vulnerabilities. Which is great for us. I mean, we'll all be employed for a very long time if we put that in place. But I think that's what's necessary. I don't think we can create something that's once and for all going to close our vulnerabilities.
Maybe in long term, we shall just discuss about this in terms of research. I think so. Okay, fine. Thank you, Dr. Amanda.
You're welcome. And I think I have about 3 minutes left, and I did get a question in the IM via private message. I hope it's okay that I share it here. The question was, will AI replace human intelligence in coming years? We could debate this all day. But my answer is I don't think so. And I hope not, because I think it's incredibly important that we continue to use human intelligence for things that human intelligence is good at. I never want to turn over the ethical decision making that we need in our AI systems to an AI. I think we need to have that human element in it to make sure that we continue to develop AI that works for humanity, that works with humans. And if I have anything to do with it, we won't have AI replacing human intelligence. Now, that's not to say that we don't have AI continuing to do more and more things that humans used to do. But I think we need to apply it in the right way. We need AI to do things that are dull, dirty, dangerous, or difficult for humans to do. But these same questions were being asked during the Industrial Revolution. During that period, they said machines are going to take over everything, and human beings are now going to live a life of leisure and sit around and eat bonbons all day. And that hasn't happened. I don't think that's going to happen with artificial intelligence either. We're always going to need that human intelligence to be part of the way that we function as a society. And with that, I think that's my time. So I will turn things back over to the moderators. Thank you all for your attention and for your questions today. I appreciate it.
Thank you so much, Dr. Amanda.